Hi, this is Sung, your online maths mentor, and today we're going to start a brand new topic. It is the topic of parametrics or parametric equations. Now, parametric equations is an extension 1 topic which extends a topic that you did in the 2-unit advanced maths course, and the topic that it extends is the topic of locus and the parabola, right? So we did locus and parabola, and this basically takes that concept and takes it another step further, okay? So parametrics is basically an addition to that, but let me tell you exactly what a parametric equation is, okay? So a parametric equation, so I've got it up here, so they are a way of setting up a relationship between two variables. Let's say you've got your x variable and y variable. You can set up your relationship between x and y in such a way that you express it as a relationship of a third variable, all right? So you express the relationship between x and y, not to each other, but to a third variable. And as that third variable changes, it will affect x and it'll affect y, all right? So x and y will change as the third variable changes, okay? So let me give you an example of what I mean. And I did say that it extends, or parametric equations extends, the topic that we did on parabolas. So let's go back and recall what the locus of a parabola was, right? So we recall that the locus of a parabola is given, generally speaking, by x squared equals to 4ay. So do you remember that? All right, so if you don't, you can go back and have a look at the 2-unit mathematics stuff, but x squared equals to 4ay. Now, if x squared does equal to 4ay, we can express that as a parametric equation. So para meaning parallel, so we've got two parallel equations, so in other words, two other equations side by side, not between x and y, but between x, y, and a third variable, say t, right? Now, why is that useful? Because oftentimes the third variable t might be time, for example. So we want to see how the horizontal movement of, say, a particle changes with respect to time, and how the vertical position of a particle changes with respect to time. And if we know how x and y both change with respect to the third variable time, then we can also work out the path of that particle eventually by using that third variable to work out the relationship between the horizontal and the vertical, okay, between the x's and the y's. Let me show you how to do this, because it can actually get pretty interesting. All right, so can you see that x is equal to 2at? All right, so this is what we're going to be doing. We're going to say that x equals to 2at, yeah, which actually means that we can work out t in terms of x. So here's what we're going to do. We're going to make t the subject of the formula. Okay, so what would that be, right? Well, it would be x on 2a equals to t, right? Or t is equal to x on 2a. Got it? We're going to do the same thing with y, all right? So we're going to say y equals to at squared, right? Which means that, say, t squared is equal to y on a, okay? Good. Or we can take that one step further and say t is equal to plus minus the square root of y on a. Now, we didn't have to do that, because the main point, or the point that we want to get across, is now that we've worked out these two t's together, we can actually equate them. All right, we can equate them together. So basically, making 1 equal 2, so equation 1 equal equation 2, you've got x on 2a equals to plus minus the square root on y on a, all right? Square both sides. If you square both sides, you've got x squared equals to 4a squared equals to y on a. Do you see that? Cross multiply, ax squared equals to 4 a squared y. Divide both sides by a. And so that means that can cancel. One of those can cancel with one of those. So x squared equals to 4ay, which is exactly what we want. That is the locus of the parabola. Do you see that? So it does work, right? Our parametrics or parametric equations basically can be combined to make the locus, right? And we do that by making t the subject of the formula for 1. And then what you can do is you can actually take this and substitute it directly into there. You didn't have to go to that step there, but I've done that just to help you out, right? So we can actually take the t, substitute it into at squared, and you will no doubt get the same thing, okay? That's basically all I wanted to do, because I think one of the things that you need to be able to do between parametric equations or with parametric equations is to move from two parametric equations and turn them into one equation. Yeah, so to take out the third variable, right? So that's an example for you to go through. But I also wanted you to see and get familiar with this. I want you to get familiar with x equaling 2at and y equaling to at squared, right? That those two parametric equations will be the parametric equation, or it will be the locus of a parabola, a traditional parabola, the locus of a parabola, okay? Now, one final thing before we finish up. This t, I've used t as our third variable, but sometimes you might see the third variable being all sorts of other stuff. So here's some other common letters that you might use or you might see. Instead of T, you might see the letter P, you might see the letter Q, you might see the letter R. In fact, it can be any letter of the alphabet, right? So be prepared for it to be any letter of the alphabet. Don't just think that the third parameter or the third variable is going to be T, because it can be anything, okay? I'll also mention something else, all right? And that's this. Remember how I said, so when I said that the P, Q, and R could be other examples of variables, often the way that works is this. Sometimes your parametric, right, or equations can be expressed as a point, right? So for example, instead of x equaling 2at and y equaling at squared, you could just have the 2ap in the x position, the x coordinate position, and the ap squared in the y coordinate position, right? Rather than expressing it like that as an equation, right? So for example, if you've got 2ap and ap squared, obviously that is a point on a parabola, x squared equals to 4ay, because we proved that over here, but that would be your point P. It'll be a P for particle, right? So it'll be a particle moving in a locus such that your x coordinate is 2ap and your y coordinate is ap squared. Therefore, if you were to use the letter Q, it would be Q equals to 2aq, aq squared on a parabola x squared equals to 4ay, okay? Because if you turn this these two parametric equations into a function or into a relationship, you will get the x squared equals to 4ay, right? So basically whatever letter that is, all right, will be, you know, the name of the point. So if it's point P, moving in the fashion of a parabola, x squared equals to 4ay, it'll be point P having the coordinates 2ap, ap squared. Okay, that's basically what I wanted to say. Again, you know, thank you very much for watching. I'll talk to you soon. Bye.